Hello, so today we're going to be working on solving linear systems by graphing. And the first thing we're going to be working on today is determining whether a ordered pair is a solution to a system. Now remember, whenever you want to do that, what you need to do is check to see if the point makes both equations true. If it doesn't work in both equations, then it's not a solution to the system. So for the first point here, we've got 1.1 comma 4. I'm going to start by plugging it into our first equation. So that was x minus 3y equals negative 5. Now if I plug in 1 for x and 4 for y, I can simplify that to 1 minus 12. And then 1 minus 12 is negative 11. And that does not equal negative 5. So now we don't even need to plug it into the second equation because we already know that it's not a solution. So we can say no, it is not a solution. Alright, so now for point B over here, we've got negative 5, 0. So I'm going to start by plugging it into the first equation. So that equation was x minus 3y equals negative 5. So I'm going to plug negative 5 in for x and 0 in for y. And so then negative 3 times 0 is 0. So I get negative 5 equals negative 5, which is true. So it worked for that equation. Now we need to check the other one. So that one is negative 2x plus 3y equals 10. If I plug in negative 5 for x and 0 for y, again 3 times 0 is 0. Negative 2 times negative 5 is that is positive 10. And that worked. So since it worked in both equations, we can say yes, it is a solution. Alright, so moving on to the next problem. Now we want to work on actually solving a system by graphing. Now you can use whatever method you like to graph. I personally prefer to get my equations into slope-intercept form first. So if I were to solve this equation for y, I would get y equals x plus 4. So I can graph that by putting my y-intercept at 4 and my slope is 1. Now when you're solving by graphing, you always want to put all of the points that you can fit on the coordinate plane for your first line, because you want to make sure it's really clear when you graph your second line where they intersect. Alright, so here is my first line. Now my second line, if I solve that one for y, I get y equals negative x plus 4. So I'm going to start at my y-intercept, and I can automatically find my intersection point is right there. So for this one, I'm just going to plot 3 points to get my line, since I know where they intersect. Now if the intersection point wasn't the y-intercept, you would need to keep plotting points until you found where they intersected. So we can see that our intersection point is right here. So we can say that our solution is the point 0, 4. Alright, so moving on to our next example. I'm going to start by solving my first equation for y. So I get y equals 3 over 2x minus 3. So if I start down here at negative 3, my slope is 3 over 2, so that means I'm going to count up 3 and over 2 to get my points. And again, I'm going to put as many on the coordinate plane as I can fit. and so now I can solve my second equation for y. If I do that, I would have y equals 3 over 2x minus 3. If we look at our two equations here, we notice that they're actually the same. So if we were to plot that line, it would fall right on top of this one. What that means is, since they are the same line, that any point on the line is a solution. So we would want to say for the solution, all points on the line. Alright, so going on to our next example. So again, I'm going to start by solving my equations for y. So my first equation, I get y equals 3 over 2x minus 3. So I can plot a point at negative 3, and I'm going to count up 3 and 2 to the right. And then I have my line. Now I can do my second line. When I solve for y, I get y equals 3 over 2x minus 1. So I plot a point at negative 1, and I'm going to count up 3 and over 2. And then over here, I'm going to be going down 3 and over 2. And so if we take a look at these two lines, we can't see an intersection point here. That's because these lines are parallel. You could have noticed that in the beginning here, because they had the same slope. And we already talked about earlier in the year how the same slope means parallel lines. So since they are parallel lines and they never intersect, we say that the answer is no solution. So to sum up what we've talked about, there's 3 different types of solutions you can have. So what we got in our first example was one solution. And that means you have 2 intersecting lines. If I sketch a picture of that, if I have my coordinate plane, I have 2 lines that look something like this. They're crossing at one point, and that would be the solution. The second type of solution I can have, like we had in our second example, was all points on the line. And what we saw that looks like is 2 lines on top of each other, because they're really the same line. So if we had a picture of that one, so if I draw my x and y axis, my line, all I would see is one line. And then the third type of solution I can have is no solution. That's what we saw in our third example. And that means we have 2 parallel lines. And if we sketched a picture of that, it would look something like this. 2 lines that are parallel, so they're never touching, so there's no intersection point. Alright, and then the last thing we want to take a look at is how to solve by graphing on your calculator. So we all know that when we graph on our calculator, you always have to solve for y. So if I solve this for y, I would have y equals 3/5 x minus 6/5. And then I can solve the second one for y, and have y equals 3 over 2x minus 5 over 2. Now to graph it in my calculator, here is my calculator. So you want to input both of the equations. Make sure that your fractions go in parentheses with a division sign in the middle. So take a minute, make sure that your screen looks like mine. Then once you have them entered, you're going to hit the graph button, and you should get a picture that looks something like this. Now we can see that the lines are intersecting here, but we want to know that exact point. To do that, you're going to hit second, and then the trace button, because that gives you the calculate menu. Then if you look, choice 5 is intersect, which that's where we find our solutions, is the intersection point. I'm going to choose choice 5. If you look down here, it's asking first curve. That means it's asking if that's the first line you want. And it is, so I'm going to push enter. Now it's asking if the other line is the second line I want, which it is. And now it's asking if it can do it, so I say yes. And it gives me the intersection point. You always want to make sure that you round to the nearest hundredth. So we would write this as 1.44, comma, negative 0.33. And that would be our solution. So again, once you have the graph, your steps to get the intersection point. So first you're going to hit second, trace 5, and then you're going to hit enter 3 times. And then your intersection point should be on the bottom of your screen. Alright, so hopefully you understand how to solve a system of equations by graphing, and we'll be able to get more practice with this tomorrow in class.